The 74LS74N chip, otherly known as a flip-flop, and this right here is representative of a 1-bit counter. So let's get started. So first two things that you need to know is what exactly does PR and clear mean. So PR means preset. What does preset mean? Preset means to override the output and set it equal to 1. The output will be equal to 1. Clear, or CLR, as I just said previously, is equal to clear. What does clear mean? Well, what happens when you say clear off a desk? You shove everything off. There's nothing on your desk anymore. So I guess a way you could kind of think about what clear is, it's literally making a 0. So it creates the output of 0. Another thing you need to know about the preset here and here is that not only do they override the output, but they're only active when they have low or 0 or ground connected to them. What's this called? This is called active low. That means these two functions of the chip are only activated when ground is connected. And they will stay dormant, or they just won't really do anything, as long as, there's 5 volts being attached here, followed by this green line here. So not really doing anything. So you might be wondering, what exactly is this chip doing then? That's a great question. So in order to understand that, we gotta look at the other inputs. So right here, we have clock and we have data. D for data, CLK for clock. D is just the data that's going inside the chip. Notice how it's doing something strange. It's going to not Q, and I'll dive into that a little bit later. Clock, on the other hand, it's connected to this little device that oscillates. And I reviewed oscillation in the previous video, so if you're not familiar with that, you should take a look at that, along with another chip design that I went over. And basically what happens is, let me explain what's happening here. So data is being inputted as not Q. What's not Q? Q, in general, is the output. So not Q is the inverse. So what's really happening is the data going into here is opposite of the data coming out. What does this mean? A good way to do this is to simply just write it out. So say, for instance, the first value that you get from this clock is 1. The 1 travels through data into Q, and the output is 1. The LED starts to, become brighter. And then the inverse of that is brought over to D. So now it's a 0. The 0 is pushed into data. The output becomes 0. So now this is off. But again, not Q is the input for data. So basically what you have here is toggling. It's going to infinitely, as long as it has power, do 1, 0, 1, 0, 1, 0, etc. And what this does is, it turns this Q diode, this LED, on and off continuously. This is what you call toggling. So let's look at another example. This is the same circuit, or it's the same chip and not the same circuit. Let me correct myself. And except this time, instead of having not Q going to D, we have Q going into D. Now, you might be wondering, oh, this is easy. The LED must always be on because D equals Q. Well, actually, it's unpredictable. We don't know what the LED will be because if you think about it, we don't know. D is just equal to Q. So that's really just saying 1 equals 1, where 0 equals 0, in a way. So what ends up happening is the chip doesn't know what the input is, because there's nothing to change it off of. So it's going to be wondering, is it a 1 or is it 0? And what happens is that this LED, it's unpredictable. We don't know what it's going to light up or whether it's not going to light up. That's why we call it an unpredictable case. So right here we have the same circuit, or same chip, sorry, but again, there's something's different. If you take a look at here, there's an inverter gate here. And what does that inverter do? Well, we have the output of Q going into data here, here, and then suddenly this inverter makes it not Q. And suddenly we get toggling again. As I said earlier, there's start to be 1 0 1 0 1 0, etc. So if you want to connect data to Q, it's better to put an inverter so that you can predict what it'll be. So since we're on the topic of unpredictability, what would happen, say, if this green line here, green wiring, well, instead of 5 volts or power, it was in fact instead ground? Well, you'd be correct in thinking that this would become active and this would become active because, as I said previously, these are active low. And this is denoted by the circle here and here. Whenever there's a circle in input, it means it's active low. So suddenly, you're overriding the output to be both 1 and 0. And a good analogy for this is that if your mom tells you to do something, like a chore, and then your dad at the same time tells you to do a chore, you don't know what to do. You know, you're befuddled, you're lost. Same thing with this chip here. The chip doesn't know what to output because it's taking 2 inputs at once, because there's active low going here and here. So what happens is you get unpredictability for this diode here. And the chip doesn't know what to do. It could be a 1 0 0 1 1 0, or it could be something else. So this is what we call another unpredictable case. So now let's look at this example. Now, in this case, preset is set to VCC, meaning that it's not going to be active anymore. Instead, what's active? Ground here, aka clear. So what will happen instead? What does clear mean? Clear means an output of 0. It overrides the output, and this will forever stay off. Unless you change the wiring, of course, or you do some sort of black magic. So that's a little review for the 74LS74N chip. By the way, this is called a 1-bit counter because if you were to use the original design, in which D was connected to not Q, this would be 0 and then 1, 0 and then 1. In terms of binary, that's literally saying 0, 1. This is counting from 0 to 1. If we were to look at this chip design instead, where we cut off the green wire from going into this clear and replaced it with power, and here we still have ground, what happens is this is not active, right? But this preset is still active because, again, there is ground connected to it. So, again, what does preset mean? It means an output of 1. So that means that because preset is connected to ground, the output will be overridden and it will forever be 1.